Um,
You want me to send it to you again?
yeah, like the one in OB is like it's all furnished, but it's kind of like furnished like an Airbnb.
Yeah.
And so I don't know, like the thing that I have one hesitation is there's a sick master bedroom.
Yeah.
With its own like master bathroom, and then you want to do this one instead?
Okay.
Okay.
We'll talk about that later, but we're going to submit an application. 1 second.
Hi, Anna.
Hi.
How are you? I'm on
Good.
duty for a few minutes, but I can still sorry.
It's wrong. I'll resubmit it.
Yeah, that's simple. Yeah, so how are you doing?
Good. How are you?
Good.
I just needed help on 5 and 6 on the practice test.
Yeah, let me take a look.
Okay.
Classwork. Oh, okay. Yeah, so what did you think about number 5?
Practice is low.
What was it?
Oh, can you hear me?
Oh yeah, I can hear you.
Oh, okay. The practice test is loading. So number 5. I was just confused on this one because when we went over a problem like this during class, my internet kept cutting out, so I couldn't really understand what was happening.
Okay. Yeah, so let me kind of walk you through the idea. So you're okay with that there's 2 trips here, right? There and back.
Yeah.
And we always try to set up unknowns, but we don't want to use too many unknowns. So like you're going to do distance, rate, and time for each of them.
Okay.
But you always want to kind of, if you see they're like in this case, there and back is the same distance. So you want to use the same letter D for the distance, and it's unknown.
Okay.
Now the
So
trick.
should I make a chart for this one, like
I
with
recommend,
the train
my
problems?
students always like to do the dirt table. That seems to work well because it's like very systematic and it helps you stay organized.
Yeah.
But kind of like each of the own problems, you fill in the dirt table a little bit differently because you have to think about like what the situation is.
So for distance, you would just put D.
Mm-hmm.
Okay. And then time for the first trip, would it be 7?
Perfect.
And then the return trip would be 3 hours.
Excellent. So the tricky part is the rate.
Yeah.
And so the thing is, what's the unknown to focus on is the rate in still water, like the rate when there's no current. So set that up as your R. Now, if you have a current, which trip? Oh, there it's a little bit tricky, by the way. It doesn't say which trip is slower, the first one or the second one.
The first one.
So that tells us that should we do R plus the current or R minus the current?
Would it be R plus the current for the first trip?
That would make us go faster.
Oh, so R minus.
R minus. And then the next one will be R plus.
Mm-hmm. So then we're trying to figure out how fast she paddles in still water.
Yeah, so you can put those equations together,
Okay.
and you'll get like D equals R plus 6 times 7, I think. No, also r minus 6. Sorry.
It's okay. And then you would just solve them.
Yeah, you can. I would do substitution, kind of get rid of the d.
Okay. Would you write them d equals r minus 6 plus 7
R minus 6 times 7.
times? Oh, okay.
Dirt, yeah, dirt stands for a distance equals rate times time.
Would you just make one negative?
Which one?
Like, because you want to cancel the d's out?
Oh yeah, you can set them equal to each other.
Yeah.
So d equals r plus r, r minus 6 times 7.
Mhm.
And the other one is d equals r plus 6 times 3. Or what was the time for the other one?
Yeah, times 3.
Right, and then you can just set those two equations equal
Okay.
to each other, and kind of get rid of the d,
Mhm.
and then solve for r. And did you get r?
I got r equals, would it be, hang on. 15.
Nice. I think that's correct.
So then that's the rate for the still water?
Mm-hmm.
Okay. And then 6, I tried setting up the table, but then I got confused for
Can you tell me what was 6 about?
it was a train from Boston to New York.
Okay, are they leaving from different, one from Boston and the other one from New York?
They depart at the same time with each other.
They leave from different locations?
Yeah.
So the idea there, the trick is the distance this time is not the same. So we don't know how far they travel, but we know how far apart the city is. So the trick you can do is you can put a d for one of the distances, and then the distance in between them for the other distance, the distance the other train travels at the moment that they meet will be 350 minus d, or whatever the distance is between them.
Oh, okay.
What was the distance between them?
210.
210, yeah. So we do d, one of them is d, and the other one is 210 minus d.
Okay.
So that's another case where it's like, you just kind of know that setup when two things meet up with each other, like coming from different directions, they have to add up to 210. It's different from the case where that one of them has to catch up to the other. When that case, or you have a round trip, in that case, the distances are the same.
Yeah. And then for time, since they leave at the same time, would it just be t?
That's right. In these cases, when it's an intersection, leave at the same time is just t. Perfect.
Mhm. And then I would just solve those two equations?
Mhm.
Okay.
I'll be right back.
Okay.
You finished?
Almost. What?
Okay, just asking.
Okay. You want me to wash it?
Yeah, what do you need to, what, Ben could watch maybe.
No, no.
I think I need to burp her and stuff.
Yeah. Okay, let me do it.
I think she's getting pretty sleepy too.
Yeah.
Yeah, you need a towel?
Yeah.
Okay. All right. Let's see. Got some people here. Okay. Yeah. How did that one go?
So they give d equals 60. So d.
Oh, hang on. For some reason, maybe it's my Wi-Fi. It's a little bit broken up. Can you hear me okay? I can hear you. Oh yeah. Try without the video.
Now can you hear me?
Yeah. Now I hear you a bit better, definitely.
Okay. I said one of the equations is d equals 60t. So then would you just plug in d to the other equation and then solve?
Oh yeah. So and what did you get for the other equation?
210 minus d equals 80t.
Perfect. Exactly. Nice. And all these equations, the reason we're doing it in this chapter is because they're all just two equations, two unknowns. They happen to be nice to solve by substitution. You don't really need to do elimination. It's kind of the same thing.
Yeah.
Awesome. Hey guys, hey Gabby,
Thank you.
Ivan, Mason. What was it?
Uh, thank
You want to message? You want to just message? Can you message the chat because it sounds a little bit broken up. Am I also broken up? Because I'm in a different room. I don't know if maybe my Wi-Fi is worse. Okay. Okay. Cool. Did you guys have Ivan, Mason, or Gabby? Did you guys have any questions?
I'm all good.
Okay. Cool. Awesome.
circumstances, I would agree with you. This is such a crazy. Do what? Yeah. What better price? What? I'm curious why you don't want to go there. You think it's CBA?
There's no like sandy beach. There's kind of not really. There's no like terminal movements there. Not like to see people like walking around. This is not really that. It's very like the building.
Do you want the 3-bedroom in Tourmaline? Casas by Del Mar? Casas Del Mar by, you know, the beach that you go to normally, Tourmaline? Or do you want the one you saw in Ocean Beach? Furnished? How small is it?
Well, the master is very large.
You need to decide today.
Hello? Yes, hey. I'm good, thank you. Yes. Great. Okay. So, yeah, I was going to call you. My mom is, she's having some hesitation about the area. So we're not sure exactly if we want to take, but we're still highly interested. So I'm gonna discuss with her. Got it. Right. Right. One second, I'll put you. Mom, the other people. Yeah. Okay. I'll give you a call back. Can I call this number or can I text you?
Yes, call this number and then my extension is 102.
102. Okay, great.
Okay. All right, thank you.
Thank you. The other people want it. But don't be, don't have to rush into, like, if you don't like that. I understand the. Ben? I'm going to give you, can I give you a phone number of this lady? It's like, other people want that unit. And I don't want to like, the Ocean Beach. They're a couple, so you guys are 3 people. It was 3,600. 3,600. And you can maybe call this lady and say, hey, can you do like a short release or something like that? You can do it for 1 month. You don't have to do it for 1 month. They might not go for it. They might go for something else.
So Sarah's in the right? Even though she doesn't verbally call me, she has to confirm it.
Yeah.
You don't have to do it.
Right. Okay.
That's what I'm saying. Let's do it.
So.
If Sarah's not saying today.
Right. So 858-272. 39.
where'd you walk that turn lane? There's a little bit of construction. I don't think it's anything to do with it. We're on the cliff, it's too far, right? As you go down the hill, there's a little house on the right hand side of the turn lane. It has construction. I don't think it's a big deal.
So, yeah.
You know it. But, okay, it's fine. It's fine. What are you gonna text them?
Well, this is just her number, whatever you, if the lady says no, or you want to,
I won't call it right now. Until you have the conversation. Right?
I think probably, fortunately.
So you want me to call her?
Maybe call her, ask her if she wanted to do this one-on-one or something like that. Or if you can,
Tomorrow? This one you can. It's either big or little. That one? I don't know. It's not mine. It's yours. I don't really care. So I'll call. I'll probably wait for confirmation. If it's confirmation, she says you have the unit, I'll say, hey, sorry, I'm not gonna take this. If I don't get it, I'll probably tell her.
also, I think this unit, as they get, you don't like it. It's not as easy to get out.
Yeah, so I'm saying, two different. Who would say this one?
This one, if you don't like it, and should try it out.
It's
Because I don't
not.
want you to lose, and it's kind of stuck in limbo again. But if I don't know, you're saying you should have because you say you're not confident of the concept.
I want it. I'm confident because I want it, but I'm not confident I'm gonna get it. That's it.
Then not 100%.
She hasn't said it. That's your unit.
But yeah, maybe talk with the lady. Okay. All right, guys. Sorry about that. Sorry about the delay. Let me get my headphones on. Okay. Okay, let's go over, today we can go over the, number 4 and number 6 as well. So let me, or any questions actually. So let me pull these up here. Yeah, let's go through, how about this? Let me do number 4 together in the class, and then 5, 6, 7, 8, and 9, I'd like to just have you guys maybe share your solutions as a group, like in breakout rooms, and I'll just jump between them and see how you guys do. Oh yeah, definitely. Yeah, so if you want to go over like in the breakout room, I can definitely address like any specific question, and then if you have like a bunch of questions, we can also go through them later as well. Or maybe we'll just do the whole thing. Let me just see here. Yeah, let's go. So I'll do number 6, and then I'll just go through most of the other questions as well. I'll ask for each question if people want to see it. So let's see here. So I'm just going to share my screen. Okay, so let's do number 6 here. Sorry, not number 6, number 4. Okay, so number 4. Sorry, guys. Number 4. Concentration is of sugar is, so the sugar in the carrot juice is 6%, and apple juice is 4%. Oh, sorry, 14%. Vons wants to send a 20-ounce bottle. Oh. A 20-ounce bottle with a blended concentration of 8.4%. How much juice should be used in the blend? Okay. Anyone kind of want to volunteer, say what they set up as their variables? Well, what are the unknowns in this question? For the concentration, by the way, is like it is a ratio. It's like how much sugar over the overall volume of juice. Nice. Ariana says how many ounces of each. So let's say A could be the ounces of apple juice, and C is equal to the ounces of carrot juice. And okay, so and now we know that we want to make a 20-ounce bottle. So that tells us A plus C equals to 20. So that's the overall quantity. And usually these types of problems have some equation that represents the overall amount. The next equation, anyone kind of want to suggest what quantity we should focus on for the next equation? And this is very similar to the blended teas. Nice, Ariana, perfect. Exactly. So when you're talking about concentration, you want to focus on the overall sugar. And it's just like the idea of like, each course has some number of credits, or each pound of green tea costs some amount of money. Here, each ounce of apple juice has some percent of sugar in that juice. So what you can do, if it's 6% sugar, you can do 0.06 times I guess I should rewrite it here. It'd actually be 0.14 times A plus 0.06 times C equals 20 times 0.084. Okay. And so I just wrote everything in percent, but really if you wanted to, you could move the decimal over. So maybe you just multiply everything by 100. So you get a nicer, easier looking equation. 14a plus 6c equals 20 times 8.4. Okay. So now we can solve this, but don't rush to multiply these two numbers. If you want to solve this without a calculator and kind of make your life a little bit easier, the trick is treat the big number 20 as if it's a variable. So don't even try not to multiply this through. So what we're going to do is let's eliminate a, for example. So if you multiply everything, let's eliminate c. So if you multiply everything by 6, just moving this equation down, you get 6a plus 6c equals 20 times 6. Good question. The point. Hang on. Yeah. So the shouldn't the 6% is 0.06, 14% is 0.14. When I multiply everything by 100, the decimal moves over two spots. So you got something like that. Oh yeah, and then it's going to be subtracted. So everything will be, you can multiply it by -6, or you can just subtract the whole thing. So subtracting the whole equation. And what you're left with is pretty nice. You'll get 8a equals 20 times 2.4. Oh, yeah, 20 times 2.4. And now, if you want, you can say, well, I know 2.4 divided by 8. I can ignore the decimal. That's just 3. So this is a is equal to 20 times 2.4 divided by 8. Well, that's just 20 times 0.3, which is 2 times 3, which is 6. Oh, I got to 8a. I got to 8a by doing 14a minus 6a. So I just subtracted these two. Yeah, so I guess I didn't, what I'm doing here is I'm just rewriting the positive equation, and I'm just subtracting the whole thing. I didn't put the minus signs. You could also put the minus signs on everything here, minus, minus, minus. That's how I got the 2.4. Aiden, did that clarify the question? Okay, cool. Yeah, so I'm not writing all the minus signs because I'm just, my minus sign is on the entire whole equation, which just make sure you're careful when you write it that way. Okay, so we have a is equal to 6, and therefore using the first equation, that would imply that c would equal to 420 minus 6, which would equal to 14. Okay. All right. Archer, did that help with the setup a little bit? Awesome. Are there any questions on the setup? Do you now see that this is exactly the same, just different wording, but the same kind of idea as the green tea problem? All right, awesome. How about another one? Any other requests? Okay, so we got 5 and 6. So let's do both of those. So number 5, this is a round trip problem. And I'll just do the setup, and I'll leave it to you to find the final answer, but we'll do the setup together, okay? So number 5, this is a dirt problem. And a lot of these also are similar to the ones examples in the book as well, in chapter 8. So distance, rate, and time. Okay, so we know that the Kayla takes 7 hours on the road. Return trip takes 3 hours. So this is 7 hours. The return trip takes 3 hours. And this is a round trip. So round trip, the distances are the same. So we can do D and D. Now, does anyone know what I should put for the first trip? Oh, by the way, the current is 6 miles per hour. Does anyone know what we should write for this box? Nice. Lily, why do you say R plus 6 versus R minus 6 for that one?
I meant to switch it
Oh, okay, gotcha. Why do you say R minus 6?
because the current, wait, hold on.
For the first one.
Wait, never mind. The current's supposed to be making it go faster, so then it would be +6.
That's right. But is the first one is going faster?
No, it's slower, so minus. I'm sorry.
Exactly. No, it's okay. Yeah, I also get mixed up on this. So the longer the time is, the slower your rate is. So you're going slower. So you're going against the current. And think about it. Don't just memorize it. Think about, okay, what's the picture? What's actually happening here? And remember, our setup is that the rate is unknown. The rate is not 6. The rate is R. 6 is the current. So the current affects your, how fast you're going in the water by either taking away from your speed or adding to it. Okay. So this is our system of equations. And then you can write D, that each dirt equation, R minus 6 times 7, D equals R plus 6 times 3. Now you can do substitution. You do R minus 6 times 7 equals R plus 6 times 3. And you can solve for that. I'll let you guys solve this one out. All right. Any questions on the setup here? Hang on, guys. I'll be back in 1 second. Hey guys. All right. So sorry, let me just go back here. Oh yeah. Good. All right. So round trip distances are the same. Okay, so yeah, so to solve this one, you just expand the answer would be 15 if you did 7r minus 42 equals 3r plus 18. And then you get 4r, subtract 4r, add 42, you get 4r equals 60. You get r is equal to 15. Okay. All right. So let's see. R equals 15. Great. So let's see. Let's go back. Let's try number 6 now. Or did we just do that one? Which one should we do? Sorry, guys. Number 6. Yes, let's look at number 6. So number 6 is the train is from Boston to New York is 210 miles. So we have 2 trains going next to each other or traveling opposite each other. So we have a Boston train from Boston and one from New York. And again, we're going to do distance, rate, and time. And let's see here. We know that the Boston train is at 60 miles per hour, and the New York train is 80 miles per hour. Oh, what am I doing here? Wrong. Sorry, wrong. So this is 60 miles per hour, and this one is 80 miles per hour. Okay. And then the time, we don't know the time, that's unknown, but it's going to be the same time for both of them because they leave at the same time. So they leave at the same time. Okay, and then the distance, would be one of them is d, and can anyone suggest if we're looking when they meet, this is different from a round trip problem. So how can we set it up if we're looking to find out where they meet? So here's New York and here's Boston. If one of them travels distance d, how far does the other one travel? So what would this distance be? You can put d2, nice, it would be 210 minus d. And that's something to be aware of. Like that is one thing to remember when you're doing these distance problems is sometimes you have round trip problems. Sometimes you have like people catching up to it, like two trains catching up to each other. But in problems where they're meeting each other from different locations and you know the overall distance apart, it's nice to write it as the second distance as 210 minus d. Okay, is that setup okay for everyone? Are there any questions on that setup? Technically, what's happening here is you can also find the relation by saying we know that the distances have to add up to 210, so therefore d2 is 210 minus d1. So there's like a third equation here, but I think it's pretty simple to instead just write 210 minus d. Okay.
So let's let me see here. So now let's move forward and solve this. So I'm going to erase, we don't need this stuff here anymore. So our equations are d equals 60t and 210 minus d equals 80t. Anyone have a good approach here? Should we use elimination or substitution? Nice. I would say substitution also. So we can just plug in this green one here, just plug it into here. Okay. So we get 210 minus 60t equals 80t. And then add in the 80, add the 60t equals 140t. Okay. Then divide by 140. And you get 1.5 equals to t. So it takes 1.5 hours to go from, for them to meet up. And then what does the question actually ask? It says, you have to read that part carefully. At what distance from New York do they meet? So we actually want to find the distance that, we actually want to find this box. So if we plug in, we get, we can find that D, plug in back here, we can find that D is equal to 60 times 1.5. So D is equal to, I don't know why I wrote it like that. We can get that D is equal to 90, and 210 minus D, which is the distance from New York, this is equal to 210 minus D is equal to 120. 210 minus 90 is equal to 120. Okay. Are there any questions on this problem? Please hit yes if you felt comfortable with the setup, and because we hadn't done one exactly like this one before, but I think if you've seen the other ones, you might have been able to figure it out. Awesome. And this is, by the way, a really famous problem to oh, was it Miles? I believe it was Miles. Okay, now I want to share with you guys, there is another another way to solve this. And it's quite nice to think about. So it's using that relative speed idea, right? So remember last time I told you that if you have two cars going towards each other, one of them at 60 miles per hour and the other one, or two trains, one at 60, one at 80, from the perspective of the first train, let's say the one in New York, imagine that that one doesn't leave the station or just staying there, right? How fast does it look like the other train is coming at it? If it's actually in reality going 60 and the other one's coming at it at 80, how fast does it look like they're coming together? Not 20, that would be if they were going in the same direction. But if they're coming towards each other, one at 60, one at 80, and you might have experienced this effect if you've ever taken the coaster and looked at oncoming traffic. It comes at you super fast, right? So it will be 140. So now think about this. Don't worry too much about like where their positions are. Just imagine that there's a red line that represents the overall distance between the two trains. So, and what's happening here is that this red line, if you visualize it, you know, it's actually shifting, right? But you can think of it, it's actually shrinking at a rate of 140 miles per hour. And so you can actually, just by thinking about relative speeds, you can bypass all of this setup and you can get to the simple idea that, okay, the trains are moving towards each other at 140 miles per hour. So their distance between them is shrinking at 140 miles per hour. They're 210 miles apart. Oh, it takes an hour and a half for something that's going 140 miles an hour to cover 210 miles. Once you get that time, then you can solve everything else. So thinking about relative speeds lets you avoid all the table and lets you just jump into this idea right away. Please use the table kind of as you're setting up the problem, but have this in the back of your mind that thinking about relative speeds could actually simplify a lot of steps. Well, simplify the setup a little bit. How many of you followed that explanation using relative speeds to just jump to that equation? Did that idea make sense? Please hit yes if it made sense, and no if that didn't really make sense too much, how I skipped those steps. Cool. Some people don't. Okay. Yeah. Think about it. Try to think about it a little bit. It's worth. Okay. A bunch of people didn't quite understand that explanation. Yeah. Have you guys just okay? Let me ask another question. How many of you have seen The Matrix? The Matrix, like with Neo, you know, and what's the Keanu Reeves? Okay, a lot of people haven't seen The Matrix. No, I recommend it because it's I think it's maybe a movie a little bit before your generation, but it's you know, it's like watching it's a part of film history. It's a good movie to watch for sure. At least the first one. I recommend it. But anyhow, in The Matrix, it's about kind of like you know, being in some sort of virtual reality world sometimes. And there's a scene where Keanu Reeves is like in a room, but around him is all white. So all the background is gone, and it's just like pure white space. It's like meant to like represent like, you know, a blank page in the computer or something like that. So if you think about two trains, usually we think about things moving, we think about the background or whatever. If you think about the trains, you know, two trains moving towards each other, one at 60, one at 80, it's really equivalent to just one train not moving and the other train moving at 140 miles per hour towards it. If you imagine the white background, there's no way to tell the difference between those two situations. And so if you think about that simpler situation where one of them is not moving and the other one's moving towards it, and they're 210 miles apart, then it's really easy. You just have to figure out how long does it take something moving 140 miles per hour to cover 210 miles. And that's how you can get the hour and a half. So that way of thinking, that observation about relative speeds that is very useful for lots of problems. Okay. But yeah, don't have to know it. You don't have to worry about it if you didn't quite follow that argument. All right, let's go. I'm going to ask you guys. I want to see how many people got to practice this. How many of you got this inequality? X. This is number. Which one was this? This was number 7. So how many of you got this one? X plus 8, absolute value, is greater than 3. Awesome. Yeah, message me if you what intervals you got or what interval you got here. Nice. Oh, careful here. Yeah, we didn't do number 1 yet. We'll go back and do 1 for sure. All right. There's a grandma and mom. Okay. Awesome. Nice. All right. So, okay. So a few people mixed up the signs. So this one, it's x plus 8. So remember that it's going to be, because of the plus sign here, the idea with the intervals that I showed you, you want to think of it as subtraction. So it's going to be, and it's not 8 away, it's from -8. So it's x minus -8 is greater than 3. So the distance x is from -8 is greater than 3. Oh yeah, definitely, Gabrielle. I'll do number 8 as well too, for sure. Okay. So let's now plot this on the number line. We have -8 is here, and we have to be more than 3 away. So here's 3. So I'm going to make this a 3, and here's another 3. Oh, sorry. What am I doing? This is out of it today. Here's a 3, and then here's -11, and here's -5. And then this one is over here, and this one is over here. Okay, so now we put this in together for our intervals. We get -infinity to -11 union -5 to infinity. Okay, so just be careful to not forget the negative signs, because it's not the distance from 8, but it's the distance from -8. And you go +3, -3. Any questions on the setup here? Oh. Okay, let's go over number 8 as well. So number 8 asks about number 8 asks about 13 to 25. And write it using an absolute value inequality. Okay, so if we plot it 13 to 25, can anyone share what we should look for first? Or how you thought about this? The middle number. And what's a nice way to calculate the middle number? You can kind of eyeball it, but what's a nice way to calculate? The average. Perfect. So we do the middle number is going to be 13 plus 25 divided by 2, which is what? 38 divided by 2, is it 19? I like 19. And nice, thank you guys. And then how far apart is 19 from the edges, from the boundary? 6. Okay, now you have to put everything together, and this shows if you can put this together, it means you really understand what the equation is saying. And again, try not to focus on, in the beginning it might be some memorization, but make sure you have an understanding of what it's saying and why you're doing what you're doing. A lot of times in this chapter, I see students just kind of trying to say that this goes here, I forgot. Well, don't be scared to forget things in math. It's okay if you forgot exactly, because if you understood it, you'd say, well, okay, I forgot. Let me think about what does it mean? Oh, it's the distance from the middle has to be compared to some quantity. And then that can bring it back. I forget things in math all the time. And sometimes I just have to kind of rethink and remember the main idea, and then it comes back. Perfect. So we get x minus 19 absolute value, the distance from 19 has to be less than 6, and we don't want greater than or equal to. Well, the way we think of the equation is just it's literally expressing the picture. So the middle number, you say the distance. What this is saying is to express an interval. Another way to talk, rather than saying go from 13 all the way up to 25, we say we want you to be within 6 feet or with six units of the number 19, and that's what the red equation represents. It literally says that, but just using math or using an equation. So the numbers 13 to 25 is the same as saying all the numbers that are within 6 units of the number 19. So all x that are within 6 units. So, and in particular, which sign? Why do I use a minus sign? Because remember that this phrase, this sentence, if we remember the argument that we went through, absolute value of b minus a, this is the same as the phrase, the distance between b and a. Oh, you can use either one. Oh, like the greater than or less than? Oh, which sign to use here? Okay, that's a really good question. So let's think about that. So that's why we have the minus sign. We're saying the distance of x, the distance between x and 19, the distance between x and 19 is less than 6. This is the same thing as the red equation. Right? And the reason we know that we want it to be less than is we want to pick numbers that are inside between 13 and 25. So like when your parents tell you, hey, I don't want you to go more than 3 blocks away from the house, you're staying close to your house. When they say, oh, hey, there's been a zombie outbreak, you got to stay more than 5 feet away, that's going to be like this example. Where here it's like there's a zombie outbreak at -8, you got to stay more than 3 feet away. So that's when the equation is greater than. You have 2 separate infinite intervals. But when it's less than, you got to stay close to a number. Did that help answer the questions? Okay, cool. Any other questions? Any part I can clarify? Nice. Okay, let's do number 1. Yeah, let's take a look at number 1. Oh, sorry. Did I do? Yeah, here, take a look. Oh, okay. I'll mention. Okay, you're good. Okay, cool. And I'll post these notes as well. I don't know if I posted the last class's notes. Yeah, for some reason, it's been really annoying because there used to be an awesome feature on Notability where I can just hit a button and it goes right to the class. But now it's like a bunch more steps. I have to like rename everything and save it to my drive and then upload it. So it used to be very convenient, but okay. So let's try number 1. Yeah, I don't remember what the answers were to number 9. We can try to do that. Wait, let's try to do that one at the end. We'll finish off trying to do number 9. Okay, number 1 is f of x equals square root of 2x plus 4 all over x plus 1. Okay, so uh, um, 2x plus, okay, so we want to find the domain. So the domain here is, we always want to make sure that the thing under the square root is positive. So we want 2x plus 4 to be greater than 0. So we have 2x is greater than negative 4. Oh, greater than or equal to 0, sorry. So whatever this expression is here, whatever you see underneath the square root, it's got to be just greater than 0. And then you can solve for that. Making sure to remember, be careful with the inequalities. So you get x is greater than or equal to negative 2. And the bottom one tells us that x cannot be equal to negative 1. This is from the bottom equation. So putting this all together, we get, we can draw the number line, and we got to go to the left. Here's negative 2, but we can't have negative 1. So the number line is going to be at 2 intervals, up to negative 1, from negative 2 to negative 1, and then negative 1 to infinity. So it's going to be negative 2 comma negative 1 union negative 1 all the way to infinity. All right. Are there any questions on number 1? And the reason I wrote here is I kind of jumped a step. Well, what I should really write below that is, or above that is x plus 1. X plus 1 is not equal to 0. And then that's how you can get to here. Isn't it a, which one do you think is a parenthesis? The negative 2? Oh, that's a, yeah, that's a parenthesis at the very end, for sure. Sorry about that. Any other, is the first one though is because it's in the numerator, it could be a 0. So that one, it would be a bracket. Okay. Any questions on number 1? Any other, does that look good? All right, let's continue. And let's try last few minutes here to do the last one. Did anyone attempt it and get some answers? Cool. What numbers did you get? Because it's easy to make mistakes. So I'm sure a lot of people have some different answers. I'm going to try to make them all whole numbers. So that's kind of one way. I do that because it's nice to know that, okay, hey, I'm doing something wrong. Let me check my steps. So, okay, let's try equation. Let's try number 9. This is number 9. X plus 2y plus z equals 4. And this is x plus 3y minus z is equal to negative 1. Nicely done, guys. Awesome. I see a few people got it right. Equals negative 1. And 2x plus y plus z equals 2. So yeah, we can pick some nice things to eliminate. I would probably focus on eliminating the z's because we see some really nice equations here, plus z minus z plus z minus z. That right away jumps out at me to get rid of the z's. But you don't have to pick the z's to eliminate. You can pick any pair. So let's use a and b, a, b, and c. So if I do a plus b, that's going to be 2x plus 5y is equal to 3. And then b plus c is going to be 3x plus 4y is equal to 1. I don't know why I wrote it that way. Let me see, 3x plus 4y is equal to 1. Yeah. Okay. And then now we want to do elimination, but now what should we try to eliminate? Why is this elimination a little bit trickier than the other ones that we've done? What should you do to both equations? Nice. You want to we can eliminate x. If you want to eliminate x, what should you multiply the top equation by and then the bottom equation by? Nice. Yeah, if you multiply the top one by 3 and the bottom one by -2, it turns out pretty nice. So let's multiply by 3. So times 3 and then times -2. This is times 3, this is times -2. You get 6x plus 15y is equal to 3. And this would be -6x minus 8y is equal to -2. Combining everything, you get 7y. Oh, hang on. Now it looks like I might have made a mistake.
You didn't multiply the other side.
Sorry. Oh, is that a 9? I forgot to multiply by the 9. Thank you. So this is going to be a 9. Awesome. And this is going to be 7. So 7y is equal to 7. Then that tells us that y is equal to 1. Once we have y equals to 1, we can plug in, hang on, y is equal to 1, and then plug into the first equation. You get 2x plus 5 times 1 is equal to 3. So 2x is equal to -2, or in other words, x is equal to -1. And now plug into any of them that you want, maybe equation C. So I'll just write here 2 times -1 plus 2, plus 1, what am I doing? Plus 1 plus z is equal to 2. And now moving things over, you get z is equal to 3. All right. And that's it. That would be the final answer, -1, 1, 3 for X, Y, Z. All right. Did you guys have any questions on any of these? On the last one here, number 9? I remember last class yesterday, there was some students who were a little bit shaky on 3 equations, 3 unknowns. Did doing this extra example help a little bit? Nice. They can't, like you saw, I made a mistake there. I'll keep it as all whole numbers. So if you're getting a fraction, say, hey, hang on, I got to go back, check my steps. Number 2 was done in a previous class, but the idea there is because it's parallel, you can set up the proportions. Oh, we did it yesterday, number 2. You can do 8/10 equal to a/35, and you want, this is number 2, and you want 8/10 to not equal to 16 over b. If you remember, this captures the idea, the first equation captures the idea that they have the same slope. The second equation is the idea that they have different intercepts. So you don't want them to be in the same proportion. Okay, any other questions? How many of you feel like you can, oh, number 10 was, oh, number 10, extra credit. Well, I'll leave you to watch the, see if you can watch the explanation again. I'll let you guys research that one. And remember the main idea, I'll tell you what the main idea was. The main idea is the total, you think about the total number of handshakes. So think about the total number of handshakes. What you realize is if you draw the graph of like people as dots and edges as handshakes, what you realize is that the total number of handshakes is an even number because it's 2 times each handshake, because everyone has whenever there's a handshake, 2 people are involved. But at the same time, you can do it individually. You say, oh, how many handshakes did each person get, and add those all together. So what you get is overall an even number is equal to an bunch of even numbers plus a bunch of odd numbers. And so what you find out here is, so just kind of remind you here, if you have an even number is equal to evens plus a bunch of odds, then that tells you that this quantity, the number of people who shook an odd number of times, the only way to get a bunch of odd numbers to add up to an even number is you have to have an even number of them. So that was the idea, that every time that you shake hands in a group, there's a even number of people who shook hands an odd number of times. We might have done this. This might have been listed as an extra credit. I don't remember. Last test, we definitely had something about handshakes as well. I don't remember if it was exactly this one as, I don't remember if I put 2 questions there. But yeah, maybe I'll also do, on Thursday, I'll also throw in another extra credit just for you guys to have some fun if you finish the test early. Okay. Any other ones that you guys wanted to take a look at? Looks like we finished almost all of them. All right, guys. Well, I'll be here for a little bit if you have any more questions. But otherwise, yeah, that's great. I'm happy. Make sure, by the way, so if you just sat in today and you didn't get a chance to do the practice test, and you're just kind of like saying, "Oh, I'm watching Daniel do these questions, and everything that makes sense to me, I can do all of this." Be careful. I've done that in math classes myself and fooled myself into thinking that, oh, I can ace the test and no problem. Make sure that even if you sat through this lesson and it all made sense, you have to, at home, well, you have to, like, when you have some time, just in a quiet room with no distractions, no computer, no notes, just print out a copy of the test if you can, or just like, write down the questions or something and redo the test. That way you really reinforce the learning, because just watching me do them, even though the steps might seem simple, and I think they are, doing it on your own is a really, really important way to kind of ingrain the knowledge. So please make sure to do that before Thursday. And I hope you guys will feel, just a show of hands, how many of you feel like you're ready to ace it on Thursday? And how many feel like you need to do maybe a little bit more practice before Thursday? Awesome. Yeah, and it's more practice. Good. Yeah, definitely. Excellent. So I encourage you to do some more practice, and a great way to do it is just tomorrow, do the questions that you felt a little bit shaky on. Just think about them, set them up again. Okay, see you guys. Caden, I will try to post the recording. I've been kind of falling behind on posting the recordings, but I will try to get them up soon. Or I'll try to get it up today so that you can see that one at least. And I'll post a note at least so you can see the notes. See you guys. Have a good day. Oh, Jack. Yes. Hey. Let's. Yeah. What time were you going to be free on Friday? What time works for you? Jack. 6 PST. Yeah, whatever time. Just tell me a convenient time, and we can set it up then. I can do 6. Is it 6 a.m. Pacific time? That's a little bit early for me, but it's not a big deal. I can do that as well. Yeah. What's a convenient time on Friday? Okay, great. Let's do that. Okay, so yeah, and then can you also email me? Or do I have your email? Just shoot me an email, and then this way I have your email, so I can email over you the exam. Okay, great, awesome. I'll have it. Thank you. Any other questions? Did somebody say something? Alrighty, guys. I will see you on. Oh, thank you. Thanks, Jack. I'll see you guys on Thursday.